Good morning, everyone. Welcome back. How are we feeling today? Great. That's good to hear. Perfect. So welcome to day 2 of our networking events. Before we get started, I see we have Erik here together with us. And I just wanted to take the opportunity in a moment to say a big, huge thank you to Erik, Thun Hotel Lofotens, and the entire team for the feast that we were privileged enough to have yesterday evening. It was really, really a memorable dinner, Erik. Thank you very much. You have set the bar very, very high now. For today's program, I would like to start by introducing our next session. Yesterday, we dug into several themes about Arctic sustainability. From market development, we spoke about collaboration, responsible marketing, a code of conduct for our guests, and also how we can support local well-being. Today, we turn our attention to climate. As we all know, climate is not a distant concept in the Arctic. It is already reshaping our seasons, our landscapes, the conditions under which we operate, and also the reasons and the times our guests are visiting. Our first presentation this morning takes us straight into this topic, climate change in the Arctic. Together with us, we have our first speaker, Anna Luomaranta. She is a group leader and researcher at the Finnish Meteorological Institute, working in the extreme weather and climate change group. Her research has focused on winter climate in a changing environment, and she also coordinates several research projects linked to climate change. Anna, welcome on stage.
Thank you, and good morning, everyone, also from my behalf, and thanks for the invitation to join your meeting. This is actually my first time in Lofoten Islands and in northern Norway, so it's very nice to be here. Okay, so I will tell you something about climate change in the Northern Europe and Arctic area. Let's see. Okay, and this is the outline of my presentation. So first, I will talk about some observed changes in climatic conditions in the Northern Europe and Arctic area. And this will probably be the longest part of my presentation. Then I will show you some estimates of future changes. And at the end, I will have a few slides about tipping points. You may have heard about those, but let's discuss them also. Okay? No. So let's begin with this fact that Arctic is warming fast. Here you can see European Arctic annual mean surface air temperature starting from 1979. This is now calculated as an anomaly from the mean value of 81 2010. So basically all the blue bars show the years when the annual mean temperature in the European Arctic area has been colder than the mean value in 81 2010. And all the red bars show the years when the mean temperature has been warmer than this 30-year mean value. Well, as you can see, the red bar starts to dominate starting from 2000. So the warming is really happening. But we can also see that there is a year-to-year variability. So there may be still cooler year and warmer years also in the future. And the map on the right side shows local amplification factor. And this now tells us, or here the warming is compared to the global warming. So it shows us the areas where this local warming has been stronger than the global warming. So everywhere where the number is positive, so the red areas, the warming has been stronger than the global mean warming. And for the major part of the Arctic area, so inside the Arctic Circle, warming has been at least 4 times as fast as the global average. So the northern areas are warming faster than the world as a whole. Okay. Why is it empty? Okay. Okay, like this, yes. And of course, this warming will cause rapid changes in the Arctic biological and ecological processes, and different livelihoods will be also affected. Here you can see an example on the photos of an ecosystem change. They are from the same place in the Arctic. The first photo is taken in 1949 and the second one in year 2000. And during these 50 years, you can see that the bushes and other vegetation has spread to higher altitudes, and it has also grown more dense. So altogether, there is now more vegetation in year 2000 than it was in 1949. So these kinds of changes are occurring in ecosystem level. Also, the Arctic warming increases the likelihood of extreme weather events. On the graph here, you can see an example of temperature distribution. The dashed line shows now the distribution for the previous climate, and the solid line shows the temperature distribution in the new climate. In the previous climate, we can see that the probability for cold weather was higher, but as the distribution has shifted to right, we can see that the probability here, this area, has decreased, so there's less cold weather in the new climate. And this is also true for the warm side of the distribution. So where we used to have less hot extremes, now the probability area for them is larger. So these kind of changes will have significant and potentially also nonlinear responses for abiotic, biotic, and anthropogenic systems. The current understanding of how Arctic terrestrial life and ecosystems will respond to climate change is based on data of long-term climate averages and at core spatial resolution. And also, we can see these changes in all seasons, so in both annual level and also in seasonal level. Here is an example. I'm sorry, these maps are only for Finland because I didn't have other figures of these, but here you can see an example of seasonal changes in temperature and also precipitation. So the first figure shows the temperature trend in all 4 seasons in Finland. This is now calculated starting from 61. And we can see that the winter has warmed the most during these last 60 years. It's been about 0.5 degrees per decade, the warming in the winter time. And the same is true also for precipitation. The lower figure, we can see that the wintertime precipitation has increased the most. There's also an increase in other seasons, but there are more regional variability than in winter. It's kind of more spread to the whole country. And this is also true for Norway and Sweden. So these kind of large-scale changes in temperature and precipitation, they are pretty alike in all the northern countries. Yeah, so changes are not as strong in all the seasons. But of course, we have also short-term climatic variability, which is linked with seasons and extreme weather events. And these extreme weather events can have a strong influence on the Arctic environment also. Here is an example of shorter precipitation events. So this is now trends in daily annual maximum precipitation for the period 1969-2020. And this is now calculated for station observations. So basically, everywhere where you can see blue dots in these stations, the daily annual maximum precipitation has increased. So it rains more during one day. There are also these brownish dots. They show stations where the precipitation has decreased. So there's also regional variability always when we look at the climatic indicators. Okay, so this is just the same text again. But then, sorry, this is not working as it should. Yeah. Okay, so we can see the change also throughout extreme events, as I already mentioned. And these kinds of extreme events, they include, for example, transient periods of extreme winter warmth, or summer drought, or high wind speeds. And we have developed many kinds of indicators to describe the changes in Arctic conditions at FMI. And here are just a few examples. First one is the growing season length. This one shows the mean value of growing season length in 1991-2020. Maybe the more interesting figure is the one on the right, because this now shows the trend in the growing season length. So basically everywhere where you can see red values, the growing season has become longer in the Arctic area. Especially here in the Northern Europe, the red color is quite strong. It's 4 or 5 days per decade this change has been. And these kinds of changes in growing season length has all kinds of impacts, of course. It may, of course, benefit the agriculture, but then it may also cause northward or uphill shift in many species ranges, which then, of course, affect the sceneries. And then, of course, it may also benefit some insects, because also their active season becomes longer. And then some pests and diseases can spread their ranges to new areas when the growing season becomes longer. The second example is rain on snow events. So this shows now the mean value in 1991-2020 for these rain on snow events. So meaning events when we have snow cover on the ground, but then we have liquid precipitation falling. And here is the trend for that. Not much change, but we see still some change, and it's especially in the Northern Europe, the coastal areas, at least here, and also some change in the Siberian area. These kinds of events have also many kinds of impacts. For example, in the ecosystem level, for example, the starvation risk for wildlife is growing, because when the liquid precipitation falls on top of the snow cover, it may then freeze, and this forms this ice crust, and it becomes very difficult for the wildlife to dig food under the snow. And of course, these may also increase the risk for midwinter flooding events, and also these kind of events may accelerate the permafrost thawing. Here is just to mention that we have created this kind of data set that covers, includes 18 seasonal and extreme event variables, and it's openly available data for everyone. Let's then move on to the heat waves, because heat waves are one of the clearest impact of the warming climate. These kinds of heat waves, they can trigger many ecosystem level disturbances. For example, they can increase the risk for wildfires, or increase the risk for frozen soil or permafrost thawing. And of course, they may cause health risk for humans, but also heat stress for plants and animals. Here you can see this is now an index called heat wave magnitude index. It's percentile based in the maps, so it captures both the duration and the intensity of the heat wave. So basically what we see in the maps, it's the maximum value of this heat wave magnitude index. The greater the number is, the more extreme the heat wave is. So the more red color, the stronger and longer lasting heat wave has occurred. So first, yes, like this. First, when we look at this map, so 5079 mean value, this is actually the maximum value for this period. We can see that there are only in some areas this bright red color, so meaning that there has been extreme or very extreme heat waves. But when we compare the map to this later time period, so 93, 2022, we can see that the stronger red colors have spread to large areas in the Arctic. So these kinds of very extreme and extreme heat waves are experienced in wider areas nowadays than we used to have. And there is actually an estimate for that. So during this latter period, roughly 86% of Arctic experienced an extreme heat wave. So let's dig into this heat wave a bit more in detail, because in summer 24 we actually had a record warm summer in Lapland. It was exceptionally warm also in the whole northern Fennoscandia and Svolvaer also. On the figure on the right, again the wrong button, yes. Here you can see now the station observations for 3 stations. So blue is Sodankylä, green is Karesuando, and this yellowish or brownish is Karasjok. And these are long time series, so the observation started already the late 18th century. And now in all of these 3 stations, we experienced, or we broke the record, previous records for the summer mean temperature, which was set by 1937. And the map here, this map actually shows the ranking, the temperature ranking for this period starting from 1850. So it was the number 1 highest temperature, summer temperature in quite wide area here. And we can also ask that what was the contribution of climate change to this kind of temperature record? I will answer that later on, but first I will also want to show you the estimates that we have made when we compared this temperature record to 3 ring data sets. So in Lapland, there are 3 ring reconstructions available to indirectly estimate the summer temperatures. Now, the figure here, the red color now shows the station observation in Sodankylä, and the other curves, the other colors, show actually the 3 ring reconstructions. So we can see that they actually correspond quite nicely. So we can compare now these records made here to the longer data sets of 3 ring data. And here are 2 examples. The other data set starts from the year 900 maybe, but the other one, it's 2,000 years long. And in in these 2 reconstructions, the warmest summer has been so far the 1937, and this was now exceeded in 2024. So we can actually conclude, when we combine this information from the station observation and these 3 ring records, that this summer 2024 was actually the warmest in northern Fennoscandia for at least in 2,000 years. So something that the ecosystem here really haven't experienced. Okay, but what about the climate change impact on this summer heat wave event. We have developed a method at FMI with which we can assess how often these kinds of extreme heat waves can occur in the current climate and also in the pre-industrial climate without the climate change. And using this method, we have estimated that this kind of warm summer that we have had in 2024, the probability for that would have been 0.07% in the climate without the climate change. In the today's climate, the probability for that was 6.27%. And when we compare these probabilities, we can actually calculate that this event in the today's climate, it was 96 times more likely than it would have been without the climate change impact. This is now calculated for Sodankylä station observations, but these results are consistent with Karesuando and Karasjoki as well. And also this mean temperature was 2.1 degrees higher than it would have been without the impact of climate change. And here you can also see the temperature distribution shift. So the green now shows the climate in the at the beginning of the last century. The blue shows now the climate of today. And then we have also estimated that how this distribution will continue to shift by the end of by the middle of this century. It's this red line. So the probability for this kind of summer heat at the middle of this century is already 26%. Okay. Many kinds of extreme event trends in the Arctic area have also accelerated. So in this figure that I will shortly show you, these trends have actually been calculated for different areas in Arctic, so that the Arctic area is now separated into clusters based on basis of similar climatic conditions, so mean annual air temperature and precipitation sum and interannual temperature range. Now I suggest that we concentrate on this orange area. So it now shows the results for Northern Europe. So there are many kinds of extreme event indicators that have been calculated for these areas. Let's have a look at these. So summer warmth index, and when we look at the orange curve, we can show that it's going, see that it's going upward. Then there is freezing degree days, the trend is going down. Then there is snow cover duration, again the trend is going down. Heat waves, orange curve may be a bit difficult to see, but it's going up. Then there's atmospheric dryness. Well, that's I would say that it's not that clear, at least in the Northern Europe area. And then the rain on snow events, that actually shows quite a large increase in the trend. Winter warming events, lots of variability, but still I would say the trend is going up. And then there is these high wind speed events, but there's not really that clear trend. Okay. Then we also have these small bars in the figures. What does that mean? It means that we have calculated these trends separately for the whole time period. So for the period of 1950 to 2022, and then for the shorter period 93-22. And these have been compared in these bars. So the latter bar always show the trend value for the latter time period. And we can see, for example, here that the latter bar is higher than the bar for the whole time period. And this is true actually for almost all for these indicators. And this means that the trend is accelerating, so that the trend during this latter time period has been stronger. We can maybe almost see it in some figures. So we can really conclude based on this that the frequency of these extreme events has increased sharply, and particularly this is true for the Northern Europe cluster. So the change is becoming faster. Okay. We have also identified the areas where these extreme events have or haven't occurred during the study period. And now here, the gray colors, so the areas in Arctic where there's no observed extreme events. Then we have the brown colors. It shows the areas of past areas of extreme events. And then the green color shows the areas, the new areas of extreme events. So when we compare these colors, we can actually see that the green color is kind of covering more of the land area than the brown. So it means that these extreme events spread to new areas where we previously haven't actually seen them at all. And over nearly 1/3 of the region, there's at least one new extreme event occurred in this study period. The largest increase have occurred in this for this rain on snow event, so it's been about 11% change in there. So based on this, it's true that Arctic ecosystems are being increasingly exposed to previously unseen climatic events also. Okay, let's move on to these future changes then. Let's begin with this figure. Here we can see the change in the annual mean temperature in the Fennoscandian area. So this is now calculated north from the Arctic Circle in the land areas, starting from 1950. Now in this figure, the black curve shows the observed mean temperature. It's calculated as 11 years running mean. And now the colorful curves show the future temperature projections. And how can we estimate the future? We use greenhouse gas scenarios. So these are scenarios that are developed so that the societal development and the climate policy actions are estimated, that how will they affect the temperature change. And based on these estimates, we have, I will show you now these three scenarios here. These are the most commonly used scenarios when the future estimates are being made. If we look at the red curve, this is a scenario of high emissions. It describes a world where the climate policies fail and the emissions grow fast. This corresponds to global warming of 4.4 degrees by the end of this century. But because the Arctic areas are warming faster, here it would mean almost 7 degrees warming by the end of this century. Then we have the middle of the road scenario. This is a world where the emission restrictions are partly effective. And this means by the end of this century, globally, 2.8 degrees warming. But here in the northern areas, it's almost 5 degrees warming. Then we have this green curve, and this is now the Paris Agreement world, where we limit the warming globally under 2 degrees. But in the northern areas, it would still be around 3.5 degrees warming. Currently, we are on this path globally. So we are on our way to less than 3 degrees warming. So the next estimates that I will show, they are all based on this scenario. So estimates of how, for example, winter conditions may change according to this scenario. And of course, I have to say that in reality, the warming is, of course, not this smooth. This is now presented as mean values, but there is always year-to-year variability also in the future, of course. So some examples of what it will mean in summer and in winter. Let's begin with the winter. So in the Northern Europe, thermal winter will become shorter in the future also. And thermal winter means now the period of the year when the daily mean temperatures stay below 0 degrees. This is now an estimate of the change estimated by the middle of this century, so around 2050. And so the winter length will decrease largely in the Northern Europe, but here in the northern areas, it's mainly, I would say, 30 to 40 days shorter. In the mountainous areas, a bit less. On the other hand, in the coastal areas, it's more than 60 days shorter, the thermal winter. The second figure shows the probability for absence of the thermal winter totally. Well, here the probability is still pretty small in large part of the Northern Europe area, so 2 to 5% maybe. So we will have thermal winter largely, but it will just become shorter according to this scenario. What does this mean, for example, for the snow cover? It will mean that the continuous snow season will become shorter at both ends. This is now the mean value for the continuous snow cover season that is calculated for the current climate. This is by the end of this century, and this is the difference between these two. So this shows the change. It becomes shorter everywhere in Northern Europe. Of course, the change is weaker in the north and especially in the mountainous area. But it's still largely 20 to 40 days shorter, this continuous snow season. On the other hand, these kinds of scattered snow cover days, so outside the continuous snow season, they will increase in many areas in Northern Europe. So this is now, again, for the present climate, these scattered snow cover days. This is for the end of this century, and this is the difference. In red areas, these kinds of individual snow-covered days will increase, and this is true especially for the coastal areas here in the north, and also in southern areas in Finland and in Sweden. And of course, the maximum snow water equivalent, which now means the amount of snow, will decrease. But in northern Finnish, the trend is about minus 2% per decade. In coastal areas, a bit more. But this is not a very dramatic change, so the snow cover season changes are mostly seen at both ends, also in the future. And here is also an estimate for the rain on snow events in the future. Now in the blue area, so basically north from the latitude of 50 degrees, they are increasing these kinds of events. So basically, this is occurring in the same areas where the precipitation is increasing and the temperature is increasing. So areas where we still have substantial snow cover in the winter, but still the probability for this liquid precipitation increases, and this leads to increase in these kinds of events also. And this is also calculated for this century, this trend. Okay, let's move on to summer. Also, the thermal summer will change. And this is now the thermal summer is means the period of the year when the daily mean temperature stays above 10 degrees. It will become longer, largely. 20 to 30 days in large areas, or 30 to 40 days here in the north. And the second figure shows the probability for very long thermal summer, so more than 20 days. the probability is actually quite high, especially here in the north, so 70 to 80% increase in this. And of course, this will mean that the heat waves will continue to expand and intensify also in the future. So by the end of the century, it's possible to experience a summer with severe heat waves occurring everywhere in terrestrial Arctic. And these are now the same definition that I showed earlier, that this is the change in severe heat wave land areas. This is the extreme heat waves, and this is the very extreme heat waves, and this shows the percentage of the land area that those cover. So larger areas of land will experience these heat waves. Okay, I will now move on to this tipping points section. This is a topic that's, at least in Finland, being regularly mentioned in the newspapers because there are new studies, and that's why I thought that it maybe would be relevant also to discuss this here a bit. So what are the tipping points? I don't know if you are familiar with this concept, so let's discuss this a bit. So there are several tipping points in the climate system. Here is the map that shows many of these tipping points. And this map also shows the temperature, the global warming thresholds for these tipping points crossing. What happens when a tipping point is crossed? This means a shift in the climate system balance, so large, often irreversible changes that may take centuries or millennia to kind of so that the situation becomes back as it was. What are relevant for Northern Europe? So of course, probably all of these are relevant for all of us, but maybe the most relevant for the Northern Europe is the melting of West Antarctic ice sheet. It's here mentioned, because this would lead several meters of rise in sea level. And of course, this is relevant for the whole globe. And also very relevant for us is the Atlantic meridional overturning circulation collapse. And then the melting of boreal permafrost, it's put here, the mark. This would lead to accelerating warming and also large damage to infrastructure. Okay, well, the melting of West Antarctic ice sheet could occur, according to this study that I'm referring to, it could occur already below 2 degrees of global warming. But this is a slow process, so the sea level rise would continue hundreds and thousands of years. So it's not like that we will have several meters of sea level rise during this century. And then the amok collapse and melting of permafrost would occur above 4 degrees global warming. But this is only this is based on this one study. But let's discuss this collapse of AMOC a bit more. So what is actually AMOC? I don't know if you are familiar with it, but it's a slow ocean circulation which is caused by differences in temperature and density in the ocean. And it's relevant for us because it brings warm water north and it transfers cold water south. But due to climate warming, this AMOC is predicted to weaken. It's because of melting of Arctic sea ice, which then changes the density of the water in the northern sea areas. So this is predicted to weaken during this century, but the timing for possible collapse is still uncertain. However, we have indirect observations and direct observations. Based on indirect data, AMOC is already weaker than in thousands of years. But the direct observations are from a very short time period. So based on this, it's difficult to say anything certain. The latest IPCC report stated that the AMOC is very likely to weaken over this century for all considered scenarios. However, it also says that an abrupt collapse is not expected before year 2100. However, after this latest IPCC report, there are several new studies that stated that the probability actually for the collapse could be higher. So what would it mean? Here are some examples of impacts, what could occur here then. Of course, the collapse of AMOC would cool the whole northern hemisphere, but the strongest cooling would occur in northern and northwestern Europe and also the surrounding sea areas. Winters would cool the most. For example, in Helsinki, we could experience minus 40 degrees in wintertime. But there are still disagreement with different climate models about the intensity of the cooling. There are some models where actually the climate warming would cancel this cooling, which is caused by the AMOC collapse. Still, in the northern Europe, impacts seem to be stronger in the low emission scenario. So this is a bit paradoxal. If the emissions stay low and the AMOC would still collapse, then actually we would have cooler conditions because the warming isn't strong enough to cancel the cooling. Whereas in the high emission scenarios, so large emissions, strong warming, then that would actually cancel a part of the cooling that would occur here because of the AMOC collapse. So this is actually very complicated processes and kind of a paradoxal effect. Anyway, this kind of large north-south temperature differences would lead to intensification of storms and also shifting of the jet stream over northern Europe. And this kind of cooling would also decrease the precipitation and increase the aridity in the area. But still, there is no scientific consensus of the exact impacts and also of the exact timing of the collapse. So this is an issue that still needs a lot of research. Okay, I'm coming to an end in my presentation. So let's sum up a bit. We already know, we have seen that the Arctic climate shows significant and widespread changes. And nearly 1/3 of the Arctic region is experiencing unforeseen climatic extremes. And these kinds of changes, they affect the ecosystems, biodiversity, and livelihoods. They face risks which emerge these kinds of changes in temperature, precipitation, growing season, snow period, and extreme weather events. Many kinds of seasonal changes are widespread and they dominate, and the changes in these extreme events, they can be more localized. Anyway, the northern Europe can be identified as one of the hotspots of Arctic and climatic change. And as for the tipping points, crossing the tipping points will change the scenario predictions that I also showed you. So if really there is a collapse in AMOC, then the scenarios that I showed you, they have to be recalculated because then the conditions change that much. But we know that the AMOC will continue to weaken, but it is still unclear how close the possible collapse is. But anyway, climate change impacts are large, even without fast changes in the AMOC. So we can really say that actions are needed for adapting to the changing conditions. And of course, the further we go in the time, in the future, the changes are more strongly dependent on the greenhouse gas emissions. So fast reductions in emissions are needed to avoid stronger impacts than we already face. Thank you.
Thank you very much, Anna. This has been very, very interesting and, shall we say, slightly worrying, maybe a little bit more than slightly. It's everything that is changing is affecting our businesses directly. So do we have any questions from the audience? I have one question there. Yes, sorry. I think this is something very relevant for all of us. So let's use maybe 1-2 minutes.
So my question is, have they done the calculations when the collapse has been done and how it would look like up here? And the question, where is the best place on earth to have your house in 50 years if this happens?
Okay. As for the calculations for the AMAC collapse, there are research going on, and at least my colleagues at FMI, they have made some estimates, but they are, if I remember correctly, they are from the point of view of forestry maybe. So, and really about the growing of trees and these kinds of estimates. And I now remember the results, but this is an currently developing and ongoing research area, and of course at FMI, for us it depends on funding that we can actually research or study. So, but our aim is also to kind of develop this part of research. And the other question was about the location. Well, I don't know. I cannot answer that.
One more, maybe? No. Okay. But thank you very much, Anna, for taking the time and being with us here today. Actually, this presentation and all the information we got sets a really, really good foundation, not only for today's program, but also for a lot of upcoming conversations that we can have regarding resilience in our sector as well. So thank you very much.
Thank you.
A big applause to Anna. And now that we have actually heard from Anna what is changing, we are going to hear from our next speaker. And together with Laura, we are going to explore how we can respond to these changes in the tourism sector. Laura Hokajärvi is a project manager for Mountain Resilience Project, which actually Finnish Lapland Tourist Board is a key partner in. Laura, you will walk us through how tourism businesses in northern regions are adapting to climate change, and she will also lead us into a workshop building resilience in our industry. Please welcome Laura on stage.
Thank you, Alexia, and thank you, Anna, for setting the stage. I think that's quite worrying, actually, to hear about these things. Before we go ahead, just a few words from myself. As you know, I work for Finnish Lapland Tourist Board, and it's been 2 years now with this Mount Resilience project. And I've been working in travel and tourism industry for more than 30 years. And within these 2 years, I've kind of became also a climate specialist, not an activist. Travel and tourism industry doesn't go very well in hand with sustainability and all the climate change issues, as you all know. But we still can do things to, first of all, adapt to the climate change, and then do some sustainable and responsible actions within the travel and tourism industry. But let's see first what our pilot companies. We have few videos here. And the company owners will tell you a little bbit about how they are adapting already, what kind of things they have already seen in the nature happening, and how it's going. Let's see. was Margit from Tsahkal Hotel from Kilpisjärvi. Tsahkal Hotel is also a member of AETC, so most of you already met with Margit. And then we have a company from Utsjoki, so let's look at that as well. Nice summary pictures from Utsjoki as well. So a bit worrying news as well from both of the companies, totally different kind of companies. Now we're going to go in more deeply how tourism businesses adapt to climate change in northern regions. Mount Resilience is, you may ask why Finland is involved this kind of project, which is handling the climate change issue in mountainous areas. So of course Finland is part of the Scands, and we used to have big mountains as well, but now we are focusing in this project into the northern Finnish Lapland areas of Enontekiö and Utsjoki, which are the two municipalities working as a pilot areas in this project. It's been running now for 2 years, and we have selected 10 different companies from both of these municipalities, and we are now in the beginning of a training plan and training sessions on climate change adaptation for them. And also this kind of interviews and photo shoots are part of the project as well. As you know, Finnish Lapland area is the northernmost region and very sparsely populated. And the reindeer herding along with the tourism makes the backbone of the local economy. And in this project, we are not trying to control or hinder the effects on the climate change. We acknowledge it, and we help the companies to adapt to it. And our mission is to provide practical tools for the companies, not just the theory part. Boring slides, but I'll walk you through it. There's not too many slides anyways. So climate change is already reshaping tourism. Climate change is not a distant scenario. It's something that the northern tourism businesses face every day and need to adapt to it and have already adapted to it. Most visible change, probably the snow insecurity when the season begins. You probably all remember 2018 Crapland in the UK headlines. And December used to be reliable as well. Now we see delayed snow cover, rain on snow events, icy surfaces, and more frequent freeze-thaw cycles. So one day is -30, another +5. This impacts everything on the tourism businesses, from creating safe snowmobiling trails and tracks to dog sledding, skiing, ice fishing, even photography tours. There's more extreme weather and weather changes, storm winds, heavy snowfall, rapid temperature swings, intense rainstorms even heat waves, which were quite rare in Lapland 15 years ago, also affect the summer tourism and has an effect for the reindeer herding industry as well. My husband is a reindeer herder. This summer there was the first killings of the reindeer because of the heat. Of course, there's a lot of effects on the infrastructure, the roads, ski slopes, trails. They all face new stress. Maintenance costs will rise and have been rising. All the skiing centers need to gather the snow and keep it during the summer as well, and they have to also make snow before the season starts. And also the safety issues in the roads. We all know that our rising amount of independent tourists in the northern areas, they will rent a car and drive around these icy roads, and even our own transportation is in trouble, as we saw last winter. Of course, it has effects for the nature and the culture, especially within the Sami culture, reindeer herding. And there might be business implications, cancellations if the snow isn't there, higher operational costs, stress on the staff and the companies, reputational risks, and of course safety considerations. That's why adaptation matters. Tourism businesses need to be able to function even the weather conditions change rapidly. Adaptation creates systems and procedures that prevent disruptions. That's kind of the main idea on the adaptation planning. Of course, the visitor safety is the foundation of trust. We have to have clear protocols, what we will do or plan ahead if there's weak ice or storms or heat waves, or the trail and track conditions are insecure. And adaptation often supports sustainability by rerouting trails away from sensitive areas. We try to, of course, prevent erosion, avoid all wildlife disturbance, and manage all visitor flows. This is especially important in the high ecological value areas that we all have in the Arctic. Probably the companies that cannot adapt to climate change in the early phase will not be competitive on the business sector. Climate challenges are shared challenges, and adaptation should, at its best, strengthen the partnerships between tourism companies, reindeer herders, municipalities, landowners, and environmental authorities as well. But there could be also new opportunities. Adaptation can lead to new products, new seasons, new forms of collaboration, and higher quality visitor experiences. So climate change does not only threaten us, it could also force innovation. Then I would like to give you some practical examples, and maybe you, as many of you are travel and tourism company representatives as well, what can you do if you haven't done already? Probably adaptation in your companies, in your destinations, in your areas is something that you have already keeping like for granted. It's not something that you plan or take ahead. It's something that you already do. So we have the 10 pilot companies in our 2 demonstration areas. And these pilot companies represent different types of tourism businesses. There's hotels, there's cabin owners, there's camping area, there's guided tours providers, experience providers, restaurants. And all of these businesses operate in a sensitive environment in the fell areas in the Arctic, close to Norway and the Arctic Ocean as well, where the weather changes can be sudden and snow conditions highly variable. For example, like this Tsahkal hotel that we saw with Margit's thoughts, it could mean that adaptation is designing packages that work in the autumn time, as she said, that she sees the all year round tourism very strong in Kilpisjärvi area, but also midwinter, which is not like the high season in Kilpisjärvi, as it is in other parts of Finnish Lapland, and also in the springtime when the mid-Europeans do not travel to Lapland anymore after end of March. Guided tours companies such as we have, Margit's husband Ville with Lapland Guiding in that same spot. Or, for example, we have in Hetta Näkkälä Adventures, another pilot company. Adaptation is probably more on the safety issues, flexibility and the route and track options and choices. They should have different kind of options for different snow and ice conditions if the lakes and the rivers haven't been frozen yet. And also things like up-to-date weather and avalanche information when planning tours and adjusting the group into that. Also, adaptation can mean offering indoor or semi-indoor experiences when the weather is so bad you can't go up in the fells or even in the softer activities. So they could build products around local food, culture, storytelling, which are less weather dependent programs. Maybe also they could focus, for example, in Utsjoki, which is very close to Norway, could focus on cross-border, cross-season products that do not rely on the stable snow conditions, cultural tours, scenic routes, autumn road trips, and nature photography. And we have to always remember the cooperation with reindeer herders and the local communities to ensure that the land use is sustainable and culturally respectful. So where to start when you are beginning of the adaptation in your own company or your destination? So there are a few steps and tips in here. The climate sensitivities need to be identified. Which parts of your business or your destination or area rely on snow, ice, specific temperatures, river or lake conditions, wildlife behavior or customer expectations. Then mapping your climate risks, what disrupts your operations, what increases your costs, and what threatens safety. Then step 3, creating scenarios, asking what if. What if in December there's no snowfall at all? What if the storms in the autumn time, for example, or in the summertime become more frequent? And what if summers become too hot for long hikes or experience programs? And then choosing at least 3 actions for the next 12 months, because it's not like a speedy job to do. Here are some examples. You could develop a low snow version of your main activity, as many of you have already done. There's cartwheels behind the dogs and the reindeer. I just saw a video from Rovaniemi that they had these rubber tires in the traditional reindeer's legs. Not probably the original idea on that, but workaround. Of course, then if the tracks and the routes are not safe or unpredictable, you have to think about the alternative routes or locations. For example, when talking with Petra, they told that in Utsjoki there's this lake that they knew that you can't go there in December. That's known fact for last 10 years, 15 years. And they saw that there were new companies coming to that area and starting their activities and going to that lake already in December. So they are not sure if these new companies even know about these things around the nature. And she also said they have to always think about alternative routes because of the reindeer, but also because of the snow conditions. Guest information should be improved. That's one example. Creating real-time updates. We had very unfortunate happening when two mother and the son were killed in an avalanche in Pallas not so long ago. Probably the avalanches in Finland, it's not something that we need to or needed to worry about too much in the past. And I was just talking with my former colleague from Ylläs that like 10 years ago, in that kind of weather that was in Pallas on that day, no one would go there. But nowadays there's a lot of independent travelers that just want to explore and go, and they were very experienced skiers. So maybe the conditions were too harsh. But they have developed this avalanche warning system after this incident. Of course, the staff need to be trained for extreme weather decision making, and you have to have the alternatives for different kind of weathers. Maybe investing in better weather monitoring, and of course cooperating with the reindeer herders and landowners on these issues. So hopefully small steps lead to a big change. That's, I won't bore you anymore on the facts. We are going to have a workshop next. And this is going to be fun. I'll guide you through the things. But before that, if you have questions or comments, we have a few minutes time before we start the workshop. So, any comments? Everything's clear? Good. Okay. Then we can start preparing for the workshop. We are going to imagine the future. This exercise is called Future Newsroom. And it's a very simple idea. You will imagine a future headline about tourism in your region. And you will be thinking about what's changing now, what opportunities might appear, what kind of challenges could emerge, and how would the communities and businesses respond. You can also think about cooperation between our northern countries. So we have 6 tables. There's quite many of you, but I counted 34 maybe. So it should be 6 persons, 5 or 6 persons in these tables that have numbers in it. So now we don't have to mix you up. You can choose your best buddies from your own country because it's easier to communicate with your own language. How many people from Finland? Raise your hands. Finland. 1, 2, 3, 4, 5, 6. Yeah. And Lisa can join as well into the Finnish table. Maybe here is the most Finnish people. So Finland number 1, of course. Then rest of you must be from Sweden and Norway. So I see Sweden at least here and Norway over there. So you can locate your buddies and go on the same table with them. I'll bring the instructions to the tables as well. So there's paper, there's soft pens, there's coloring pens, there's glue and there's tape and there's some magazines and scissors. So go ahead. I will bring you the headlines that you don't have to think of them by yourselves. I'll bring the headlines and the instructions to your tables and you'll start artworking. There we go.